You are watching the MPiec Web UI video tutorial series. In this video, I'll teach you how to back up and restore the control system using the Project Archive feature of the Web UI. Hi, I'm Matt Pelletier. Here's a quick preview. The Project Archive file contains all the data you'll need to back up or restore the controller, servo amplifiers, and motors. Receive this data as a zip file to back up and later send the zip file to the controller to restore. The servo amplifiers and servo motors are restored separately, but all the data is contained in the Project Archive. Now let's go through this in more detail. To follow along in this tutorial, you will need connection to one of our MP3300 IEC and Sigma 7 demo units. If you would like remote access to one of these demos, please request by email to training@yaskawa.com. You can see how this works in the remote connection e-learning video. Another document you'll want to refer to is the quick reference guide for the MPiec series controllers. The first section here lists detailed step-by-step procedures for using the Web UI. We'll be focusing on section 1.8 and beyond for receiving the project archive, sending the project archive, and starting up. The demo you're connected to is currently a working control system, but we can't be exactly sure what's running on it. So if you haven't already, please log in. I recommend you use the Chrome browser for this training. You log in as admin with capital A, password MP3300 all caps, and navigate with me under the Setup menu to Archive. And here you can see the files stored in the controller's flash memory. These are all the files the controller uses to run, including the ladder logic, user units, cam tables, variables, and servo parameters. There may be a copy of the source code which it does not use to run. It's just up to the programmer to include it here or not. Any data that is unique to the particular controller is not part of the archive, but instead is stored in SRAM, and this includes the IP address, the date, the time, the alarm history, absolute encoder offsets, and the current value of each variable within the controller's program. First, let's back up the contents of this controller and receive these files as an archive. This is section 1.8 of the quick reference guide, and we're already on step 3. At the top of the archive page, you simply click receive, and again receive, and the file will be saved to your PC just like any download in your browser. You could navigate to your downloads, and you'd find the zip file or different zip files that you've created. In a real machine, you'll want to hang on to this file and save it to the network directory or with whatever system that you have in place for backing up the data on your machine. I previously backed up a demo system like this one using the archive feature just like this, and it's part of your class materials called Archive Web UI. The controller was working perfectly when this archive was created. So our task now is to completely restore the demo system using only this archive and the Web UI. The control system consists of 3 main components: the controller, the servo amplifiers or drives, and the servo motors. And so the restoration will be completed in 3 steps with a system reboot between each step. We'll send the archive to the controller. We'll write the parameters from the archive into the servo amplifier, and we'll reset the encoder and send multi-turn limit to the encoder from the amplifier. And we have detailed click-by-click instructions in section 1.A of the quick reference guide. The controller hardware is already set up. We have a quick start video on that. Motion is stopped. We're logged into the Web UI, and we have obtained the project archive file. So we're now ready for step 5, send the archive to the controller. Okay, let's check that remote I/O. Everything's connected. I think I'll throw that over to the right-hand side instead. And we have the archive page up under the setup menu, archive, if you need that again. You probably already see it. It's the send to controller button. You then need to add archive. Now navigate to wherever you have saved the class materials folder and find that archive_webui. That's part of the class materials. You open it. Now, do you do clean install or add replace only? That really depends on the scenario. If you're starting out a system and you want to get rid of all previous data, then of course you do clean install. But if you want to save any recipes or CSV files, CAM tables, and this is just an update to an existing controller program, then you could do add replace only. We're starting from scratch, so we'll do clean install and send and install. You can see here it confirms we're installing archive. And after a few seconds, that display goes away and you'll see all of the files appear. So that is sending the archive to the controller and installing it. And the next step here is number 6, to reboot. That's up here at the top, reboot, and again confirm to reboot. We can keep our eye on that reboot here through the web camera. Looking here at the controller. Right now the lights are off, it's rebooting. And there we go, we got ready and run. So the reboot has completed. See, I do have an alarm on the servo. Don't worry about that yet. Step number 7 is to send the drive parameters, so let's go through that one. Up to the setup menu, you have drive parameters. And on the left, you can compare to or set the factory default parameters. You don't generally want those unless you suspect a problem with the amplifier parameters. You normally want to verify with the user parameters, which are part of the project archive that we just sent. You could verify whether or not you really need to send them or not by clicking verify. And if there is a mismatch, it'll tell you what it is. And it looks like there are a couple, so let's write all the user parameters. And when completed, you see that they've all verified. The drives are good now. We just need to reboot. You'll do a lot of reboots when you're setting up a system. Reboot and again reboot. Look at that camera. You'll be able to tell the drives reboot because they turn off just for a second. There, they blink off right there. That's the controller rebooting the drives. The servos now have the parameters, and the reboot of all the amplifiers has been completed. So it's time to move on to the motors. There's this alarm here, A810, on the amplifier. And you can look at that alarm under the alarms page. And the problem is this alarm 8810 encoder backup error. All power supplies to the encoder have failed. This is because we have removed the control power here with this hardware connection option of the Z-axis, and also disconnected the battery. So if the battery is disconnected from the absolute encoder when the power's off, then the absolute encoder can't remember the position and it gives us an alarm. So the next phase is to show how to recover from that. And this is the condition you'll have if you ever lose this motor cable connection to the encoder, such as when you're setting up for the first time. This is step 9 of the quick reference guide, and it involves this motion control panel and a Java applet. This part seems to work best at this point in the Chrome browser. You'll go to Operations, Motion Control Panel. You must have Java installed on your machine. If you're wondering about that, what I do is type in Java in the Start menu. And if you get some of these programs, then you're likely to have Java You can follow the link to install it if you don't have it. Otherwise, what you'll normally do in this screen is to click Download and Run Externally. We'll keep the file and launch this web controller applet. And you see this applet runs in a separate window. A little too big for my screen here. Let me fix that. And once you have this window up, you need to clear this alarm, encoder backup error, by going down to the Drive PN tab, Drive PN, select the axis that has the alarm in the pull down here. That's the Z axis for me. And click ABS encoder init and OK. You notice the alarm is not gone. I do recommend, as long as you're in here, you might as well do also multi-turn reset. This will clear alarm ACC0 if you're using multi-turn in the encoder. Doesn't hurt to do it. Let's click OK. Again, you're not going to get this alarm to clear by hitting clear alarm or just by clicking these buttons. You do have to reboot the amplifier. So we can close this engineering tool. It doesn't survive reboots very well at this point. Go to status and then reboot as many times before. You can pull up that camera to see those drives reboot. The controller is rebooting. There's the reboot. And we're back online with no alarms, no more encoder alarm 8.810. So I'm going to suggest that as part of this tutorial you go through this again on your own and see if you can restore the controller and clear that alarm 8.810. You might even want to mess this up again by disconnecting some of the hardware. And you see there's some variables here under status that indicate the value of some variables in the program. In the certification test for this training, we'll have you look at these PLC variables as the answers to some of the questions in order to tell whether or not you were successful in installing the project archive. That's part of the certification test. So go ahead and disconnect that absolute encoder battery, disconnect control power. See there, that amp turned off. We lost communication to the other drive. Turn it back on, and don't worry about the top part of the interface yet. See if you can recover from this. Thank you for watching this video, and remember yaskawa.com/IEC for more information on the MPiec product line.